Sin x plus cos x. Does anyone remember off the top of their head what result it was? What did we get for auxiliary angle? What was our r? That's easy. What's the amplitude? It's root 2. So I'm changing this. It's sine plus cos. So sine's out the front. So if I can choose any form I like, I'll put sine at the front. This is a plus, right? So it's going to be x plus. And what was the angle? What was our alpha? Pi on 4, right? And you got that from a and b are both 1. So cos alpha will be 1 on root 2, and sine alpha will be 1 on root 2. So there's where your pi on 4 comes from. So this is equal to 1. Okay? So you can get this, and now how do we go about simplifying? Divide through by root 2. Okay? Now, just like I did before, I changed the way I said my domain to make sure I got the right solutions, yeah? So I went from x to x on 2. You do the same thing here, because this function is not in terms of just x either. It's x plus pi on 4, right? So now, draw an arrow over here. I want my middle in terms of x plus pi on 4, so that means I add pi on 4 to both, or every part of the inequality. Okay, so I'm thinking of pi on 4 to that, to 2 pi plus pi on 4, which is 9 pi on 4. Okay, good. So now, when I think, what solutions can I get for this? Well, again, this is an exact value, and it's the exact value for what base angle? What's the acute angle that fits 1 on root 2? It's pi on 4, right? So I'm getting x plus pi on 4 being equal to solution 1, pi on 4. Okay. And does that check out within the domain? Yes, just barely. Okay. What's the next solution I'm going to expect? 1 on root 2. What's the other solution, or next solution? It's going to be pi minus my angle. You think about it in terms of quadrants, if you like. So A, S, T, C, it's positive, so it's pi minus my root angle, which is 3 pi on 4, as you said. Okay. But, sorry, start again. I'd usually be finished at that point. Like 2 solutions, no problems. Okay. But my domain is a little different, right? So in fact, this first bit is not included because it's 0 to pi on 4, and I have to add a little extra bit. Okay, and that little extra bit happens to matter because it just gets you to the angle that you want. Okay, so what's that angle? It's right at the end of the domain, right? 9 pi on 4. 1, 2, 3 solutions that fit my domain, and I want it just in terms of x, so I'll take pi on 4 away from everything. That gives me 0, 2 pi on 4, which is pi on 2, and 2 pi. Okay? Now, in this case, I mean, we generally go with t results because it sort of makes things simpler. I think in this example, it doesn't really. Auxiliary angle is a superior way to go about this, okay? But you still need to be able to recognize both of them, and sometimes they'll stipulate you should use this.